Good evening, everyone. My name is MD Ashik Ali. Today, we are so excited to kick off our presentation on the buck boost converter rectifier trainer kit, which are created as a part of our lab class project under the name of StudyWorks Group. Our project was guided by our respected teacher, MD Abul Khair, a lecturer in Tripoli Department, Green University of Bangladesh. The team members which contribute to the project are Nanpar Paul, Solomon Hussain, Abdullah Jubair, Mahi, Rico Khatun, and myself, MD Ashik Ali. Here are the outline our presentation to help you the following along easily. We will cover the all topic in this presentation. First of all, we will talk about introduction to explain the project purpose and goal. Then we will talk about the component and specification, a breakdown of all part used in the kit. Then circuit diagram, details of the circuit and how it's work. Then real-time application where the buck and boost converter are used in real life testing and result. The purpose and outcome of our testing, and we will talk about the video section. That's mean when we are testing the circuit in our lab. We will talk about the process in this testing and result section. Then we'll talk about the conclusion and the future scope, final thoughts, and what we can improve. Well, go through the each section step by step. First of all, I would like to introduction our presentation. Our project focus on the creating a buck and boost converter rectifier trainer kit. The kit show how voltage can the increase and decrease effectively, which are the important is the powering many device. For example, a buck converter can the reduce voltage to save the charge a phone, while a boost converter can the increase the voltage for the use the solar power system. The trainer kit board the learning tools and the practical demonstration of these principles. Now let's look the component we are using to the build this kit. The main components of our trainer kit are the 555 timer IC, use the generated pulse for the controlling the circuit. Then the power switching ensure the smooth operation by the controlling the power flow. Then the capacitor, for capacitor we are using 0.1 microfarad capacitor and 1 microfarad capacitor. It's help stabilize the circuit and store energy. Then the resistor, we are using 1 kilo ohm resistor and 100k variable resistor. Control the circuit flow and allow the adjustment of output. Then the diode, we are using IN4007 diode used for the current rectification. Then IRF50 MOSFET, a key switch in the component in the circuit. Then the inductors, 60 microhertz and 4 microhertz storage energy to help the voltage conversion process. These components play the important role in ensuring the circuit workflow well. Now I will hand over it to Nankumar Paul to explain the circuit design. Thank you.
Thank you, Ashik. Now I will explain the circuit design of our buck and boost converter rectifier trainer kit. Our circuit consists of three main parts. First part is driver circuit, second part is buck converter, and our last part is boost converter. Let me briefly explain each part. Now I will discuss driver circuit. At the heart of the driver circuit is the 555 timer IC. It generated the pulse required to control switching action in the converters. The circuit also includes capacitor C1 and C2 to smoothen the signal and resistor R1 and RV1 for adjusting the output. The power switch allows us to turn the circuit on and off using a 12-volt DC input. Now I will discuss buck converter. The buck converter lowers the voltage. Key components include the IRF 540 MOSFET Q1, an indicator L1, a capacitor C3, and a diode D2. Together, they regulate and step down the input voltage for low voltage applications. Now I discuss my last topic, boost converter. The boost converter increases the voltage. It uses another IRF 540 MOSFET Q2, an indicator L2, a capacitor C4, and a diode D3. These components work together to step up the voltage for high voltage applications. This design ensures that we can both increase and decrease the voltage, making it highly versatile for educational purpose and real-world application. Thank you, everyone. Now I request Abdullah Al Zubar Mahi present next topic.
Thank you, Nankumar Paul, for explaining the circuit design so clearly. Now let's look at how buck and boost converters are used in real life. These converters are very important in modern technology. Here are some examples. Battery powered device. Like smartphones where a buck converter reduces the voltage from the charger to match the battery's requirement. Solar power systems. A boost converter increases the low voltage from solar panels to power a home or charge a battery. Electric vehicles. They manage power between the battery and the motor to ensure smooth operation. LED lighting. These converters regulate voltage for efficient and safe lighting. Portable electronics. For gadgets like power banks and smartwatches, wires need specific voltage levels to function. For example, let's consider a solar power system. Solar panels usually generate a low voltage. Wires isn't enough to run appliances. A boost converter steps up this voltage to a usable level, making it possible to power devices or charger batteries. Without this, the energy from solar panels wouldn't be as effective. This shows how buck and boost converters make our technology more efficient and reliable. Now I will hand it over to Sulaiman, who will discuss the testing and result of our project. Thank you.
Thank you, Mahi, for explaining the real-life use of buck and boost converters. Now I will talk about the testing process, the problems we face, and how we solve them. First step, testing process. We build the circuit by soldering all the components together. Then we connected the systems to 12-volt DC source. To measure the outputs, we use an oscilloscope in our labs. This helps us check the voltage levels and the stability of the circuit. Step 2, problems and solutions. While testing, we noticed the circuit sometimes overheated. To fix this, we added heat sinks to the MOSFETs and other parts to control the temperature. Another issue was getting the desired output voltage. After carefully adjust the variable resistor, we achieved the correct voltage levels for both buck and boost converters. Third steps, results. The outputs was stable and the system worked efficiently with an 90% success rate. Both the buck and boost converters perform well, showing how efficiently they can regulate voltage. Here is a video of the testing process. Let me play it for you now.
আসসালামু আলাইকুম। আমরা এখানে একটা বাক কনভার্টার এবং বুস্ট কনভার্টার রেকটিফায়ার ট্রেনার কিট তৈরি করেছি এবং যেটা এখন আমরা ল্যাবে টেস্ট করতেছি। সো আমরা এখানে ট্রিপল টাইমার দিয়ে যে ড্রাইভার সার্কিটটা প্রথমে চেক করব। সেখান থেকে
আমরা এখানে 12 ভোল্ট ইনপুট নিয়েছি। এখানে আমরা একটা পাওয়ার সুইচ ইউজ করেছি এবং এখান থেকে আমরা ড্রাইভার সার্কিটের আউটপুট দেখব। তো আমরা এখানে আমাদের অসিলোস্কোপের চ্যানেল 1-এ আমরা আমাদের আউটপুটটা দিয়েছি এবং আমরা যদি অসিলোস্কোপে দেখি তো
আমাদের হচ্ছে ওয়েব শেপটা আসতেছে এবং যেটা হচ্ছে আমরা চেঞ্জ করলে এটা চেঞ্জ হচ্ছে। আমরা যদি ভেরিয়েবল রেঞ্জটাকে চেঞ্জ করি তাহলে এটা আমরা ওয়েব শেপটাকে আমরা চেঞ্জ করতে পারছি। সো আমাদের বাক এবং বুস্ট এই দুটোও কাজ করছে। আমরা চাইলে এই দুটো দেখতে পারি একটা লাগাই। সো আমরা এখন আমাদের বাক কনভার্টার চেক করতেছি এবং যেটা আমরা অলরেডি এখানে দেখতে পাচ্ছি যে আমাদের পিক টু পিক ডাউন হয়েছে এবং আমাদের ওয়েভ ফ্রন্টটা দেখতে পাচ্ছি। আমরা বুস্টটাকে চেক করব যে আমাদের বুস্ট ঠিক আছে কিনা। আমাদের বুস্ট কনভার্টার চেক করতেছি এবং আমরা দেখতে পাচ্ছি আমাদের পিক টু পিক বেড়ে গেছে এবং আমাদের ওয়েভ সিগন্যালটা। সো এটাই ছিল আমাদের টোটাল প্রজেক্ট এবং এই প্রজেক্টে আছি আমরা মেইনলি হচ্ছে 5 জন: এমডি আশিক আলী, নয়ন কুমার পাউল, ব্রিকো খাতুন, সোলাইমান হুসাইন এবং আব্দুল্লাহ আল জুবায়ের মাহি।
Now that you have seen the results, I will hand over it to Rico. She will discuss the conclusion and future scope of this project. Thank you.
Thank you, Sulaiman, for the detailed explanation of the testing and result part. To warm up our project, here is the conclusion. We have successfully built a buck boost converter rectifier trainer kit, which demonstrates the principle of voltage regulation and conversion. This kit is not only useful for educational purpose but also highlights how voltage can be controlled for different particular applications. Our project worked well with stable output and efficient performance, proving that the kit is effective for learning about our power conversion system. Future scope. There is still a lot of room for improvement and expansion in this project. Here is some ideas for future work. Battery efficiency. We can improve the efficiency for the converter by using more advanced components like better MOSFET and capacitor. Smarter system. Adding features like automatic voltage regulation or digital display to make it more interactive and user-friendly. Wider application. The concept of this trainer kit can be extended to more complex systems like renewable energy system or electric vehicles where voltage regulation is critical. Example, in electric vehicles, both buck boost converter are used to manage power between the battery and the motor, ensuring the vehicles run smoothly and efficiently. This kit could be a great starting point for standard interested in electric vehicles technology for renewable energy system. In conclusion, the project helped us to understand important concept in power electronics, and it also shown us how we can apply this concept in our real world technology. Thank you all for your attention, and we are now happy to answer your any types of question.